So I'm going to create a function add that takes arguments x and y and returns x plus y. And console log that, and it gives us 3. And another way to write this would be with currying or higher order functions. So we could have our add function actually return a new function that returns the result. And that's kind of weird, but bear with me here. So we have an add function that takes x, that returns a function that takes y, that returns the value, the higher order function. So that's currying, and you can see it gives the same result. So the idea here is that the functions would take one input and have one output. And the reason we could do that is because we can chain these functions one after the other. Another reason, or another way to think about this would be we could implement object-oriented programming, basically, for most intents and purposes. So I'll show you that here in a second. And so it looks a little verbose, but we can make this more terse. We can make the syntax a little nicer using arrow functions. And we could actually flatten this all into one line. So add takes an x and a y and gets a value. Well, it actually returns a function that takes a y that returns the value. And you could break it out like this. You could format it on multiple lines or one line. So now let me show you how you could kind of, implement object-oriented programming using functional programming or currying. So imagine we have this constructor called person, and it takes the name of the person. And then that function is going to return this object, and on this object we can call greet. And greet is going to actually say hi, and then the person's name. So this is something you could use object-oriented programming for, but we'll go ahead and do this using currying. So I'm going to have person Bob, and then if I call that, it's going to return this inner function, which we'll assign into the const Bob. And on Bob we can call greet, and it says hi Bob. So when we called person and pass in the name, we created this new function that encapsulated the state. So here's another example. You can create a new function based on a previous function using currying. Here we can create a function called hasLetterR that already has our regular expression preloaded in there, and then we can go reuse that in other parts of the program without having to pass back in that state. So currying takes functions with multiple arguments and nests them into higher order functions. And that's what an implementation would look like. You don't have to understand this. You can use Lodash or Ramda, or there's a bunch of other libraries out there to do currying. So another thing you can do is transform any function that works on a single element into a function that works on an array of elements by wrapping it with map. So you always, in functional programming, you always want to take one element and return another element. And if you ever need to pluralize that or make it operate on arrays, just wrap it in map or map it through. Your functions like filter and reduce work the same way. So here would be an implementation of map. Don't fixate on this too much, but mapping uses currying. So you would actually pass your function in here, and it's going to generate a new function that takes in or operates on an array. So just don't worry about that for right now. You guys can go read up on that and kind of work through that. That's outside of the scope of this video. But the point is, you could take code that looks like this, and you can see there's state. We have the state of the length of the array, and I, the current iteration that we're on, and we can simplify it and really just get to the essence of what we're trying to do. Really, we just want to have an array and we want to map over it. We don't want to deal with the low-level semantics of iterating. Well, most of the time you don't. And that's the idea of functional programming. So you can build these functional chains like filter, map, reduce, and your functions that operate on only one input and one output then get lifted into this pipeline, and the data flows through this pipeline, and the function you wrote actually has the data passing through it, if that makes sense. So that's the idea here. Tune in for the next video, and thank you for watching.